Next example, example 10.3, speed of light in materials. The speed of light in a certain material is 88% of its value in water. What is the index of refraction of the material? Based on the answer above, what is the name of the material? So let's say that X is the material, that is the unknown material. So we have to find the index of refraction of the material. So let's write them down as Nx. So Nx is the index of refraction of the material. And we also know that water is given. So we have to know what is the value for water. This is 1.33. And then the speed of light in a certain material. Speed of light certain material means, let's write that down as Vx. It is 88% of its value in water. Maknanya it is 88% of the value of the speed of light in water. Let me write down correctly lah. Buruk sangat. So V in X is equivalent to 88% of V in water. Basically 88% means 0.88 lah dot V of water. Okay, so let's do this. So first we know from the equation N of water, the speed of light in the index of refraction is C over the velocity in water kan. And then the index of refraction, this is also C over the velocity inside the material itself. This is based from the index of refraction definition. So that means that C is the same for both. So we bring up V water here and we bring up Vx also here. So they will be equivalent to C. So both of them will equivalent to each other. So N water V water equals to Nx Vx. So now we know N water. We don't know V water. We are looking for Nx and we also don't know Vx. But we know that Vx and V water, they can be written in this way. So this is ni lah betul lah ni N water over okay. I think this is a bit more complex, but basically this is mathematics. N water times V water, this is equivalent to Nx times 0.88 V water based on our equation over here. So now V water here and V water here can be cancelled together. So then you will get N water divided by divided by 0.88 is equal to Nx. So the answer you will get as N equals to 1.52. So based on the answer above, based on this answer, what is the name of the material? So this is glass lah. 1.52 is the index of refraction for glass. So this is most probably is also glass. Okay, next example, example 10.4. Index of refraction in the eye. The wavelength of red light from a helium neon laser is 633 nanometer in air by 474 inside the eyeball. So this is what I mentioned before. The wavelength ataupun the speed will change when light travels inside different materials. Now we have to calculate the index of refraction in the eyeball, the speed and frequency of light in it. So basically, you can just use equation for this one. First, you use the equation that relates the wavelength of material relates the wavelength of light inside material compared to in vacuum. So as mentioned before, this is the wavelength. You can write this down as lambda n equals to lambda naught over n, where lambda naught is the wavelength of light inside the vacuum, and lambda n is the wavelength of light inside the material itself. So now it is given that the wavelength is 633 in air. So basically this is vacuum lah, almost close to air lah. And then this is lambda. Lambda is 474. Inside this is lambda n inside the eyeball. So if you do this calculation, 633 divided by 474, you will get your answer as 1.34. So this is the index of refraction inside your eye. This is close to water, right? Water is 1.33. So basically, since our body is made up of, mostly it's made up of water, especially in your eyeball, there's loads of water in it. So that's why we get the answer close to water. And then we have to find what is the speed and also frequency of light. So the speed, we can use this equation before, where n equals to C over V, and Vn means the velocity in the material n. So you use this and then you calculate what V is, you get the answer as 2.25 times 10 to the power of 8 meter per second, where C is the speed of light and n is the index of refraction. And finally, what is the frequency? Frequency can be calculated using this equation, F equals to velocity over lambda. So velocity is what we have calculated here, and lambda is, you use this lambda because we are calculating it for the eyeball. You will get the answer as 4.74 times 10 to the power of 14 Hertz.